But like a thought cloud, yum, fresh human.
Yeah, straight out of Little Shop of Horrors.
Yeah.
Yeah.
It was on my list of things to do today. I didn't get to it.
Okay. It's hard.
Host disabled participant screen sharing. So
Oh,
that's over to you, Darce.
Oh, yeah, I gotta fix that. It seems to only be when we're streaming. Do I need to make a change for this? Where's the screen share button?
So in all the years I did training, I wasn't able to do that.
yeah. It's under security, Darcy.
Got it.
Okay, let's see what we can do. Desktop.
I think that's just the latest in their security patch that they said they were bringing out any day now. Oh, that is beautiful.
So let's give people a few more minutes. I suspect we're the only ones, but you never know.
That is really nice pewter casting.
Yeah. So I'm doing this on my small screen so that we don't get scaling issues on my my 2K screen.
I gotta get a piece. I gotta get some pens here so I can take some notes. I suppose I could type. I suppose I could actually type on my computer, but that's just way too. I don't know.
Well, I'm also going to be showing you some links for some of the tutorials I used. So,
okay. Well, maybe you could just.
I'm not saying notes are unnecessary, but you may not find them as necessary as you think.
Oh, well, it's more notes. Yeah. Anyway, yeah. I really like that image, though. That's beautiful.
Yeah, they got some good examples here, but those are definitely ones they took a lot of time with and polished and so on. So
yeah,
a bit cockeyed.
Yeah, yeah, but I think that comes from the original wooden model on the left. I look at the mesh on that is friggin' detailed.
Yeah, some of these are very large samples that they're doing a model of. So where did I put it? Oh, I'll go get it. Hang on a sec.
That's a putty cat.
Yep, it's a putty tat.
So this is what we're going to be modeling today.
Oh, cool. Okay.
A souvenir from Mexico.
Yeah, the dead.
So I will preface this by saying I am by no means an expert at any of this, but you know, I certainly know enough to get everyone started, and I don't have all the solutions, but I know where to point you for a lot of the solutions. So
okay. Well, I can say I know nothing other than it's doable. But the last time I tried it, I was losing a lot of hair because it was frustrating.
It is definitely frustrating, and there's no denying that. Even with this thing, which is a pretty good subject, we do find, as we'll see, that some of my models are missing a chunk right in the back of the head for whatever reason. Even with me trying to get a better image of it, it's still kind of messed out a lot.
Well, it won't work for me because I got the wrong kind of computer.
Well, as someone pointed out on the list, you can do a lot of it. You can get a less detailed mesh without having CUDA. And I'll show you how to do that as well. So I did spend a little time reviewing this stuff, so I even learned a few new tricks on getting ready for this.
Ooh.
Yeah, it's all good.
It always works that way. You learn something that you didn't realize.
Yeah.
When you're polishing the teaching apple.
So Ray, from last night's conversation, I was telling Darcy before you joined, I said, I learned something that just really hadn't crossed my mind when you were talking about the using not just the tip of the mill bit, but all of the mill bit. So more power all the way through to extend the life of the bit. Yes. And I always had just this very simplistic view, and still do, of, well, I'll be very gentle and I use 2mm plunges. And I know Darcy goes we talked about it, goes all the way through, and it always scares the shit out of me that I'm gonna break a bit. But you really just retwigged an idea that I'd sort of forgotten in my woodworking days. So you don't want to just use the edge, you want to use the whole thing. So thank you. You
You're
continue
welcome.
to teach me interesting things. And
Yeah,
pass
I was
on that
really
yeah.
interested in the adaptive clearing part
Yeah.
of the Fusion, which allows you to use the full length of the
Yeah.
flute.
Yeah.
Yeah, it's one of the things I like about working with this group in general. Even the less experienced always point out things that are just kind of interesting, and yeah, I hadn't thought of that.
Well, yeah, just the way, you know, we all approach things somewhat differently in the way we think about it. And I am always learning things, which is part of why I said, oh, I love this. Like, yeah, same thing. I'm learning more than ever.
I think there's also a case too of, as we all watch the same tutorials, I mean, we're starting from scratch, so we're not going to get it all first time, but everyone gets something a little bit different. And
yeah. Very true.
Anyway, looks like we're it, so I'm going to get going here. Hang on, I did have some notes. Just kind of an outline for what I'm covering. Let me bring that up. If I can find out where it is. There. Okay, so this is kind of what I'm going to walk you through. How to create a new project, import some images. We're going to look at the default pipeline, and I'll explain what that is, and we'll do a sample run, although not to completion, because even with a CUDA card, that can take a couple hours, depending on what it is you're modeling. I'll look how to modify the pipeline, so we can change parameters, we can add new nodes, alter it so that it doesn't require the CUDA processing, for example, and things like that. A little bit about post-processing. I'm going to look at MeshLab, but I'm not going to dig too deeply into it, just how to import the file and do some minor cleanup to it as you start to use that model for something useful. And I'm going to talk a little bit about calibration, and that's something that really isn't covered well in any of the online documentation. I just spent a lot of time discovering that. Less of an issue if you're using a single camera, but when you're using a multi-camera rig like what I'm doing, they all need to be calibrated in order to work well together. So I'll spend a little bit of time on that. And if we have time, I'll show you a little bit about the software that I've wrapped around it, which is one of the reasons why I was a little rusty on Meshroom, because I haven't used their user interface much lately. I've been running it as scripts in the background. So, but that's not really required. You're not going to be running that. So it's just me showing off if we have time. Okay, so Meshroom. So I have downloaded it, obviously. Go into the folder where it is and run it. So I am running this on Linux. Certainly as you run it on Windows, for example, you're going to get you know, just double click and off it goes. But you can also run it from the command line there too. And there are good reasons why you might want to do that. So this is the initial user interface. We have obviously no images or anything in it. But one of the keys here is this thing down at the bottom, which is the pipeline. Okay, I'll make that fit. So it'll be a little bit hard to see. There we go. Okay, so there's a lot of different steps in here. And now that I've done that, you can zoom in on it using the scroll wheel. And if you press and hold the scroll wheel, you can move it back and forth. So I'll give you a brief overview of each of the steps in the default pipeline and what it does. The first one, camera init, that's the one that holds the list of files you're going to process. Now, as you're doing multi-camera rigs like I'm doing, it will also correlate the calibrations with the image, but that's a bit of a manual process as well. Feature extraction. So this is actually a pretty core part of the processing. What it does is it looks at the image. So if I have an image of this, for example, it's going to find features of that image, such as, you know, the points of the petals or where these lines cross and things like that. And that's what it's going to use to match the different images and how it's going to try and calculate some parallax. Okay. Image matching. So based on the features for each of the individual images, it tries to do an intelligent mapping of which images overlap. So instead of millions of possibilities, it's a little more intelligent and applies some algorithms to reduce that workload. And that happens pretty quickly. The next portion, feature matching. Once we've identified common features across specific images, we'll try and match up those features. And again, that's part of how it measures the parallax between different images. Structure from motion. So this is the first point where you're actually getting 3D image out of it. It's not a full mesh, but basically it is those features in a 3D space. Okay, so there's a little more work to make that a final mesh, but once it does the structure from motion, we will actually see the features showing up in the 3D viewer, and you'll get an idea of what it is that that you're seeing as we go through the process. Okay. So then it tries to create a more complex mesh, and the prepare the dense scene is really, we're not entirely sure exactly what it does, but it basically prepares the data for in-depth analysis. The depth map, this is the part that really requires the CUDA processor. If you're going to be doing this without, then we'll see how we can bypass that as well. But the bulk of the processing for the whole timeline is in this one module. Okay, so if you have a 3-hour run, and yes, I've done some 3-hour runs, 2.5 hours is spent in that one processing. And that's why you need the graphics card, because without it, it can get very, very time consuming. It then filters the depth map to try and clean it up and so on. So these two we can bypass if you don't have a CUDA processor. Some of the other modules will use it if you have it available, but if you don't have it, it'll still run without it. But these two will not run without the CUDA processor. Meshing. So this is actually where it creates the mesh. And it takes all the data that it's just calculated and creates the mesh. We apply a filter to that to try and improve the quality of the mesh. And then finally, the texturing. This is where it maps the actual images on top of the mesh. So what you'll get out of meshing is a monochromatic model. What you'll get out of texturing has all of the images actually mapped on top of the model itself. Now, all of this stuff, the user interface is fairly simple. Scroll wheel scrolls in and out. Press and hold the scroll wheel to move back and forth. There are some minor things here. You can do an auto layout if you're doing changes. You can do it, make it fit, and so on. You can scroll these sections, and because we have a limited screen size, we'll be doing some of that. The 3D viewer I'll get to a little bit later. With each of these nodes, there are parameters, and we are going to play with these a little bit, and that can affect obviously how the analysis is done. And there's a few variables that you want to play with in there. They are all, if we scroll in on the pipeline, you can see that they're linked together. So the output from the feature matching, for example, I believe that goes to the matches folders input of structure from motion. Okay, so all of these pipeline nodes are actually self-contained programs. You can run them externally, and that's what I've done in my software. I run it through a batch process. So when you're doing automated processing like that, it just makes a little more sense. We can add more nodes to this tree. If we do a right click, we can see all of the nodes that are available. And there is documentation available for this, and I'll show you where all of that stuff is. But for the bulk of your processing, certainly until you're more familiar with what's going on, the default pipeline is going to be pretty much what you need. You're not going to need a lot different from that.
So
Okay.
Just a quick question. The default pipeline that you're showing us, is that what you get when you open Mixer the first time?
Yes, when you first create a project, it creates this default.
Okay, perfect. Thank you.
Now, one of the things that you need to be aware of, it uses local folders for calculations for temporary files and things like that. They call it the Meshroom cache. So before we start running anything here, we do want to save the project because the cache is going to be in the same folder as the project itself. When I started the program, I started in the Meshroom folder, so that's not a good place for that to be. So I'm just going to do a file save here. Okay, and I'll go to where I keep my meshes. And I create a new folder here. I'll just call that demo. Okay, in there I will call my project demo. Okay, save. Okay, so if I bring up my browser here now, okay, and I go into demo, we have that one. It actually hasn't created the cache yet, but it'll do that shortly. Now, one of the things I'm going to do here is I'm going to copy some images that I've scanned previously, oddly, in my skull folder. So I'm going to copy that whole folder, and just to keep things consistent, I'm going to put them in here. Now, all the processing it does on the images are non-destructive, so you can actually have them anywhere in your file system, and you can share them amongst different projects. It's not going to affect things. Even if you delete it from Meshroom, it doesn't delete the file. It just removes it from the list of files to process. Now, this Meshroom graph is supposed to be portable, but it's not really because it does hard code a lot of file paths in there. So if you're moving files around, it gets lost. So don't count on it being portable at all. And also, if you're going across different operating systems from Linux to Windows, for example, you're going to run into issues. Okay, so let's add these. That's the wrong mouse. Problem with working with multiple computers here. One of the quirks about the user interface for Meshroom, it is a Python wrapper around all those individual modules, but at the moment, it doesn't have a dialog to import files. So you have to drag and drop. Now you can drag the whole folder. I've had issues with that on occasion, so I just select all my images and drag those into the project.
Does that grid help with the referencing, or is that just what it's sitting on?
It does, actually.
Okay.
I mean, really, the main reason I chose it was because it was on my work table, but it actually does help.
Okay.
And we'll talk a little bit about that shortly as well. Okay, so these are your images, and you can see I currently have 43 images in there, and they're all from different angles. 43 you'll find for a scan is a bit of a small number, but depends on what it is you're scanning as well. This isn't a particularly large object, but for the one that went to the mailing list, the scan of that sculpture at the, I think it's the Arts Court, but I'm not sure about that. Anyway, that probably has quite a few more images. Okay, so you do want the images to overlap. That's how it calculates the parallax. And you want about a 60% overlap. So how many images you have is definitely going to affect the quality of your scan. The images themselves are also going to affect the quality of your scan. So one of the things that a lot of people recommend you do is go through and find ones that are blurry. So these ones in the back, for example, are a little bit blurry. I'm not going to do that here, and I'm doing that to show you an additional feature a little bit later. Okay, it doesn't have a big effect on it because if it can't find the features, it just ignores them. But you want typically something with a high depth of field, so it's got good resolution through the whole image. You want it to be stable, so if you're like me, use a tripod, or at least stop and wait for it. So there's a lot of packages out there that will let you use video, and you can do that here too, but it doesn't do that for you automatically. You would have to use another program like FFmpeg to split it up into its constituent images. One of the nice things about that is you do get high degree of overlap because you're just not moving that fast. The downside, so this is my iPhone. I got a 432 by 3024 image size versus 1024 by, or 1920 by 1024, which is what you're getting out of video. Okay, so I do get a higher resolution image just doing the still images. So there are trade-offs. The more images you have, the better model you will get, but also the more processing time required. Okay, so let's look at what's going on. So now we can see in the camera init, we have 43 elements.
Question.
The intrinsics, that's the camera. So if you have calibration, you have to enter this information. And it has things like the focal length, the camera type, width, height. Serial number is used automatically. Match them. There are some distortion parameters, which is really what you want in there. The principal point is the center of the image. So typically it's halfway through, and for something that doesn't have a calibration like this, that's the given default. Okay, so now I'm going to run it. And the way you run it is just by selecting start. There is some color coding. On the top, we have the full 100% processing. Where it's green, it's already been processed. Where it's blue, it's yet to process. There are kind of subtle differences there. Orange means it's currently running. And if it's red, that means there was an error, so it stopped for some reason. Now, if we look down at our pipeline, we can see it's in the feature extraction. Okay, actually, let's zoom in on that. And you can see it's actually done in half. And so I just selected the log here, and it'll actually show you what's happening as it's running through. Now, the reason it showed half is it broke this up into 2 different chunks. Okay, so you're going to see that for each of those as it goes through. Some of them I've had like 30 chunks on the CUDA processing for another project I'll show you a little bit later. Okay. So you can see this one, it's using an algorithm called SIFT, which is, I forgot what it's, state invariant feature transform or something silly like that. You can see we're using a CPU version. There is actually a CUDA version of that as well. So this machine I'm running on, and one of the reasons why I'm not going to be giving a lot of live demos, so I'll show part of this, but I won't let it run to completion. This is a 13-year-old machine. It's got 8 cores, but they're 13-year-old cores, so it's not very fast. Same thing with the bus going to the CUDA. Well, one of the nice things I have here is I can see where it's being used. So the GPU utilization, the baseline for this is about 10 to 15% because it's also a graphics processor. But you will see that going up later as we get into some more specialized processing. So, I mean, that's this allows me to monitor what's going on. I'm using a lot of memory here right now, but this also runs a lot of virtual machines on here. So if you're using any machine that's capable of this one, you've probably got at least 16 gig. 32 is starting to become common. So yeah, you shouldn't have issues with this. I tend to baseline around 20 gigabytes just because of all my virtual machines. So the feature extraction takes a little bit, but I'm going to let that run because I want to show you some of the other nodes as well. Some of these will pop through pretty quickly. Some others obviously are going to take a little more time. So any questions on anything so far?
Ray, did you have a question? I thought I heard you pop in earlier, or did you get it answered?
Like, can you go around a building and do a building, or is that like impossible?
Yeah, I mean, it really doesn't care the size of your object. What's really going to be affected by that, obviously, is the amount of details that you're going to get out of it. Because if you're going to do as detailed a view of the building as you're getting of the skull, obviously that's going to be an awful lot of data. So right. Yeah, it's going to affect your processing time. Is really the crux of it.
And it's be some difficulty getting the pictures, I would imagine.
Well, with a quad, you might. Like you might be able to fly around a building and get the higher angle stuff too.
There are some use cases they go through for that, and I'll show that as I go through the documentation. But yes, buildings and quads are both specific use cases they talk about.
Okay.
Not that you should be flying quads in the downtown core, but I mean, just if
Well,
around
the
your
thing is,
house
if you're
or something.
doing some real estate modeling or something like
Absolutely, yeah.
Yeah.
Well, my interest is in sculptural stuff.
Yeah.
And even if you go to a park, there are some pretty big ass sculptures that you might want to wander around and get top views that you couldn't do at a regular height.
So as this program is running, it creates this folder called the Meshroom cache. And in there, it actually has a folder for each of the nodes. So if I look at the feature extraction, for example, go back to the attributes, it has the name of the folder. So it's going to create a UUID in there, and it's going to put some files in there. Okay. Where are we? Feature extraction. So there's the UUID, and you can see it's generating a lot of files. It does have statistics about, you know, processing times, log files, all of the temporary files it's creating, and things like that. Okay. Now, that is nice because as you're running this, it's saving that data. So if, for example, power goes out halfway through your CUDA processing, all of the processing it's already done has been cached. So what it's going to do is it's going to pick up from where it left off. So you can't really affect this right now because it's actually running. But you can delete the data that you've already calculated if the cache becomes corrupted or so on. And the arrows over here means anywhere from this point in the pipeline forward. Okay, and that's the same for the duplicate and remove nodes as well. Okay, so that'll be useful. Also, you can compute up to any node. So for example, right now I'm running the full pipeline. But if I just wanted to compute the data in this one, I just say compute, and it would calculate everything up to and including that specific node. Okay, so where are we? Okay, so now it's matching the features. And again, it's got this one. This one is using CUDA here, but I believe it runs fine if you don't have the CUDA as well. It's supposed to run fine anyway. So now if I look at my CUDA utilization, it's not really high for this one. Actually, it's quite low. But again, that's where this being an older machine also affects things because you can see it's a generation 1 PCIe bus, whereas the current generation is 3 and it's 8 times the bandwidth or something like that. So yeah. But this is going to fluctuate up and down even within a module. You'll see the processing going up and down.
Just as an aside, I know I see you're using Linux. I saw in Hackaday there was an interesting article about improving performance by using greater caching complements of the great wax of memory we now have available. And there were some strategies for Raspberry Pis specifically, but they would apply equally well to a Ubuntu machine to put swap spaces in cache or in memory rather than on a hard drive because, again,
well, that actually goes a lot to the Pi. So I actually considered using the Pi as a distributed computing platform. But the problem with the Pi is it's only got 4 gigs of memory.
Yep.
So you're going to be swapping non-freaking stop.
Yep. Okay.
So
anyway,
I've got 48 gigs of memory in this box. So
okay. So you got.
I'm not. I'm not really swapping. If I go into swap, it's because of other programs in the background have just been swapped out.
Okay.
Yeah. If you're relying on swap for this, you're dead in the water.
Okay. Fair.
I mean, look at my my CPUs right now. You know, now it's not like that through the whole pipeline. It'll actually drop down quite a bit in certain spots, like when it's using the coprocessor, for example, the graphics processor. But this is pretty common through the whole thing.
Yep. Okay.
Okay, so I'm going to stop processing here because I'm not going to let it finish anyway. So I just hit the stop there. Now, if I say start again, it'll just restart. Now, it may not pick up exactly where it left off. It may restart that chunk or even restart from that module. I'm not entirely sure how how good the restart caching is, but basically you haven't lost your data. Okay, so again, we can, delete the data, we can remove future nodes, and so on. Okay, so I'm going to open another project where I've already done this processing. Okay, why is it saying start? Okay, so I'm going to show you, it's loading in the texturing here right now. I'm going to show you the outputs once you reach certain points. Okay, so this is the output from it here. It doesn't look like much because it's zoomed way the heck out. So I'm going to zoom in. Now, zooming in is, again, using the mouse wheel and hold the mouse wheel to shift. And you can see that this is just data points. So it doesn't really look like much, but you can definitely see the structure of the object.
Yep.
And the other thing you may notice is the grid is kind of askew to the image itself. And I don't know why, but this thing is always canted on an angle and upside down. It's just the way it works. I don't know what it picks for its origin. What you're seeing here are the viewing angles. So from the cameras themselves, what angle did it pick up? So I mentioned before about deleting bad data. You can see these red cameras. The camera was not reconstructed. That's because it wasn't able to get useful features out of that image because it's just a little bit too blurry. And one of the things you'll notice is all of the ones here are in the back of the head. And that becomes a little important later. And you can see what corresponds to each of these cameras just by selecting it here, and it's going to highlight the image. Okay, so you can use that structure from motion to see a bit of the data, and I'll show you in a moment how to then bypass the graphics processor.
So you can go through the cameras, make sure that everyone's in the right position, and can you delete the camera if one is in the wrong position?
Well, it's not a matter of deleting the camera, it's just a matter of deleting the image.
Yes, that's what I meant, yeah.
But I haven't observed any of these being in the wrong position. It's actually pretty good at that.
Okay.
If it doesn't get the right position, that's where it says, not able to reconstruct the camera because I wasn't able to get that correlation across multiple images.
Right.
So this is, again, the output of the structure from motions. So it's at that step. Now that's relatively little processing. So out of a 3-hour run, that'd be like the first 10 minutes. So it's not necessarily a bad idea to do that and just see if your image makes sense. Look at the camera arrangement, see how many cameras are being ignored and things like that. Okay, now moving around in here, let's make the viewer a little bit bigger. So it's just a matter of grabbing with your mouse and you can scroll around. It is visualizing a 3D object. You see you have what's called the gizmo here. So you can select one axis and kind of try and rotate it on that axis. But yeah, there's definitely some skill involved in positioning this in 3D space. And it becomes easier with time. Now, as it processes all of it, you will get the texture at the end. Okay, so it's already loaded. I just need to enable it, and I'm going to hide that structure from motion. And here we have our head.
Oh, wow. Now, that's incredible.
There are some issues. So, for example.
Well, you were missing. Yes.
There's a big chunk at the back.
Because of the missing images in the previous. And it looks like.
That being said, I went back and I rescanned this to fill in a lot more at the end, and it's better. But I still have missing images. There's something just about that back end that is a little bit problematic for the software.
Shadow, maybe.
Now.
Well, there's a glare on a couple of those images. Like there's a bowling ball glare.
Yeah.
Anyway, which may show up to the software as,
Oh,
as an
absolutely.
object or something.
And there's a few things you can do to try and address that. Obviously, the original lighting is a big part of it. So you want this thing well lit.
Right.
You want to try to avoid using the flash.
Mm-hmm.
Let me bring up a website with a list of pointers.
I was going to ask a question there. If you go back to the picture there, why is your mat, the green mat, so bubbly?
Well, basically because when I was taking my images, I wasn't concentrating on getting good ones of the mat itself. So, I mean, in order to make that less bumpy, I could have taken a bit of different images and so on.
Yeah. Yeah, I downloaded 50 pictures of a rock. Just someone said this works with mesh, yeah. And I just did start, and prepare dense is already done. It's now using depth mat, the one you take most time. But I did the whole thing, and I started after you started. So mine, 2-year-old laptop could actually handle that stuff so far.
Yeah, and I'll actually show you guys how to do that here in a moment as well, because that's actually a very useful tool for when you're playing with parameters. It runs a lot quicker, so you can actually see some of the effect of some of the parameters just by doing that first and then applying the higher quality. So some shooting prep tips. Actually, I'm starting to get dark here, so while I think about it.
Yeah, I had the sun glaring for a while there, and I had to close the blinds. And now I've opened them.
I've got a good north-facing window, so in daytime it's great light.
But it gets dark at night. It's surprising. It's like gravity. I don't know.
But yeah, in the shooting preparation here, number one, your scene or object should be well lit. Mm-hmm. Okay. So the scans that I showed you there today, they were just a single overhead light. Certainly if I were doing that a little more professionally, I would want to do the lighting a little bit differently. Avoid the shadows and reflections. And again, if we go back to that image, where's my Meshroom? Where did you go? There it is. Okay. You can see that there's big shadow underneath there, and that's probably part of why that back end is missing. Certainly a contributing factor, I know for sure.
Would it help in terms of photography to put it on a dowel and float it in space so you could get angles from below, or is that just a pain in the ass and I just did a bunch of work for nothing?
The answer is yes to both.
Yes, it's a pain in the ass, and yes, it helps.
No, it definitely helps. So the more you isolate the object that you're looking at, the easier it's going to be for cleanup afterwards and stuff like that. Okay. But there is a caveat to that. When I look at these images, mm-hmm. One of the things about this mat is it gives you extra reference points.
Yeah.
Right. Sorry, let me scroll this. Okay, so each of these is another feature that we can look at. So if I bring back the structure from motion, you can see that there's a lot of feature marks on the mat itself. Mm-hmm. So if you've got things that are, got a curve or something where they don't have a lot of distinct features on them that it can match against, the mat can actually help. Similarly, if you're using a turntable, this mat would hurt a lot. So one of the things I first tried to do, for example, to fill in that back end was go back and rescan some shots of that part. But the skull had been placed in a different orientation, so all those background features were different, and it totally messed up the software. It wasn't able to do anything with that at all. So if you've got it on a turntable, you want a pretty neutral background.
Okay.
But if it's stationary like this, having all those extra reference points, that actually helps quite a bit. Some other techniques that have been used are lighting, for example. So you can shoot the same image multiple times with like a horizontal stripes and then vertical stripes and then polka dots or something. Anything to try and put a pattern on that surface that's going to give it a feature that it can compare with an adjacent image. Okay. Give you that parallax. Okay, so let's go back to that list. I'm looking over my shoulder because my my controller's on the third monitor over here. Don't use a flash. Now, I did reshoot this with a flash, and it actually turned out fairly well. But yes, when you get those reflections, that can definitely affect the quality of your image.
Mm-hmm.
Don't change the focal length. If you've got an SLR, keep it at a fixed focal length, because if you're changing the focal length, it really changes its internal calibrations and how it does its calculations. Okay, moving objects are bad, as I've already mentioned, because it's picking up features that aren't consistent. The object of interest should fill most of the image, and that's so you don't get a lot of crap. One thing you'll find, for example, looking at my image, I'm used to working with this on a bigger screen now, but if you look at this, you can actually, okay, not so much with this one, but some other scans I've done, you get a good view of all the crap that I keep in my workroom. Because it will actually go in behind you quite a bit and take all that stuff. Take images with a minimum side overlap of 60% and a frontal overlap of 80%. Those are rules of thumb. You can get away with less, but obviously this will help improve it. For each shot, move to a new position. If you're using a turntable, you can rotate the object. If you're not, if you don't have that neutral background, it's better for you to move. Don't take multiple images from the same spot. You don't want to have duplicate images, even if you're just offset like a few centimeters for each one. You're better off offsetting and just, you know, cover the area nicely, but you can discard images that aren't blurry. So the ones in different patterns, that's what I mentioned where you're doing like the you know, stripes and things like that. So there is a company in China that produces some commercial gear. They actually have only 4 camera posts, but they will light you using patterned light so that they can get the shape specifically. Avoid shaking. Nah, I'm not so good at that. The more images you have, the better. You can always delete the ones that you don't need. You'll find that you think you've taken a lot of images, but it turns out to be only 20 or 30. So yeah. So for objects not on a turntable, give it a structured background. So yeah, in that particular case, that matte worked well. In the case where I'm photographing people, you know, just having patterns behind the person, like even a picture on the wall, it's giving you that extra reference point. And we're being joined by my backup trainer. So transparent and reflective objects. I'm actually going to show you another project I did. This one was just, when I first started doing this, I just grabbed the first object I could find. So it was a bit of a fun scan. It's just a toilet paper stack.
COVID emergency.
This was actually when I first...
yeah, I know.
I'm loading in the texturing here now. So this one's interesting for a few reasons. Okay, so let's get rid of the structure from motion. You can see that this is actually pretty good for a lot of reasons. For one thing, it was the first one I did. It's only 20 images of it. Now there's definitely holes in the back, but that's because I didn't actually get the camera all the way around the back, and that didn't surprise me at all. But one of the features that's missing is that metal piece at the top. So if I make this a little easier.
No, I see that.
Okay, so that's missing. It's just too much glare. Okay, so there are a few things you can do for that. Someone had mentioned using polarized light. A cheap trick is just like some talcum spray or something like that to give it something that's a little less reflective as a surface. Now, in this particular scan, I had the opposite problem of what was noticed in the skull scan, in which the highly textured floor came out really quite nice, but the fairly smooth toilet paper came out a little textured. Now, for the toilet paper, there's a few reasons for that. One is it's a pretty uniform color, so there aren't a lot of features on it. It's also a very small number of images. There's only 20 images in this, so that's not really sufficient. Okay, so I'm going to go back to the skull. And I'll show you how we can do the processing without the video card. Okay, so I'm going to zoom in on our pipeline. So basically the parts that require the CUDA are this one, the depth map and the depth map filter. One of the really nice things about this particular user interface design, and if you've used Blender, you're actually kind of familiar with this because it uses a very similar style, but it's all these nodes and so on. So what I'm going to do is I am going to duplicate all nodes from the depth map on. Okay, so again, the way I did that, duplicate node, but click on the double arrows so it's all of them. Okay. And I'm going to delete the depth map filter. Oh, wrong one. Excuse me, kitty, you're in the way. Did I do that right? Yes. No, I need to delete the depth map. So remove node. And the depth map filter, remove node. So what I'm going to do is I'm going to jump directly from the prepared dense scene to the meshing. And the way I do that is I select the input to the dense scene, and that goes to the input of meshing. And the output from the prepared dense scene is actually going to be used as the images folder for the texturing. So the output, connect to the texturing. Okay. So all of these are calculated. What I want to do now is compute this node.
Do you click start or something, or does it, or it was really fast?
No, it's not that fast. Where is it? Have I already done that? Okay, so what I'm going to do, delete data from there. Yeah, I guess so it had used the cache value, so yeah.
It was still pretty fast, but
yeah, so I mean, it certainly is significantly faster. So a lot of the mesh work it's getting is from the structure from motion.
Mm-hmm.
Now, one of the things you'll notice is the texturing doesn't always show up. This texturing is that one. So when it's done, it may show a load data, but if not, you can double click on the node and that'll add that texture to the list in the scene. Let's do the log here. There you go. You can see it's processing. So it does that for each of the images in the list.
when you run these jobs, you just load them up and run them overnight? Is that what you usually do, or?
Well, so for what I'm doing with my camera rig, I've got a bunch of software that's wraps all of this stuff in its own thing. So I submit it as a batch job to I have my single machine configured as a cluster. So I get to use all the cluster batch management and things like that. As I get my updated machine, whose CPU just arrived today, finally, I could add that to the cluster as well. So I can actually distribute the load amongst all available processors.
Okay.
But yeah, you can certainly run these overnight. There is provision within Meshroom for farm computing. So it assumes you have a farm set up, and it assumes you have a launcher created to actually launch it. How you configure that is not documented anywhere I found.
Right.
And you're going to find that is pretty common with Meshroom. So actually, while that's going, I'll show you a bit about documentation. You are going to find it frustratingly light. So from the Alice Vision website, you scroll down, join us on GitHub, brings you to this page. This page, there we go. Okay, so this is basically a wiki. It does have some help in there. There is a new manual going, but it is still missing a lot of information from the old manual. So I have a link for the old manual that I'll send you as well. Okay. So the manual, this is the old manual.
Yep.
That's not it. And this is the new manual. So you'll find that, yeah, it's just missing a bunch of stuff. Okay, so as we go through the guides, tutorials, and so on. Yeah, some of this stuff is really just not very good, but the original manual is actually better set up. So this is where I got the notes for shooting preparation. That is in the new one, but I can't tell you where it is. I know it's not available today, but there's all that stuff. So one of the nice things about this is it does have information about the default pipeline, so the algorithms being used, and some references to the original academic papers. Which gives you an idea about the origin of this particular software. So really, it was just putting a wrapper around research software and making it all work together. It is actually pretty well done, but there's definitely some holes in the user interface, such as not having a file browser to import files, right? So you are going to see some things like that. And also things like choose an algorithm. Why are we choosing this algorithm? Well, here's the research paper. Yeah, there's a little bit of that. So I will talk a little bit about that at a point here shortly, but it does have those descriptions. So the reconstructions, the sparse reconstruction, which is what I'm doing now without the CUDA, and the dense reconstruction, about how those differ. So a little more details on that. So some information about what happens when structure from motion fails, so you don't get a good image out of it. How can you go back and fix some of that? Then we get the complete node list. So all of the nodes in the available within Meshroom are documented here. Again, just big on enumerations, but not so big on why you would use this value over that value. For that one, again, they point you to the research papers. So there is some basic knowledge that you need to come up with. Now, I will talk about feature extraction. So algorithms available. The one that we're using currently is called SIFT. And that is actually a patented algorithm. So if that's of concern to you, you need to be aware. But it is a more commonly used one. That's the one that has good libraries out there for CUDA-based runs, so it'll use that one. Another one is called Hack613, and it's a totally different algorithm, the details of which are well beyond the scope of this particular presentation. But what I will point out is that the Hack613 algorithm tends to be particularly good on getting features off of skin tones and things like that. So for example, what I'm doing with my scanning rig, I definitely want to be doing Hack613. Now you can use both of these in conjunction. And what that's going to do is just give you more features to match. Okay. Obviously, if you're scanning a building, that may be problematic because you just have so much data. But even for like 100 images or something like that, you're not going to see a super big increase in runtime. It just gives you more data to work with. For each of those, there are different implementation details. And again, the difference is, yeah, it just tells us what the name of difference is, but doesn't really tell us what the practical differences are or when you should use one over the other. So there is going to be some experimentation involved. That's where those multiple pipelines, so where you diverge and duplicate nodes and so on, you can then change the parameters and compare the outputs and see which is working best for your particular workflow. So the other thing that is shown on here, this good tutorial for beginners is actually good. That's not just an empty claim from them. And that brings you to this page on Sketchfab. So this is a good step-by-step on how to walk through from the image acquisition to the UI, basic workflow. So this is a lot of what we've already covered here. Visualizing and exporting the results. And they do have some videos on that to show you examples. One of the things they cover that I don't really get into is the mesh simplification. And Ray, that software that you sent to me the other day, that's really what this is for. So this will do it. The software you showed us will do it better. But really, to use that with Meshroom, you have to do it after the end of all the processing. It's not something that you can incorporate into the pipeline easily, unless you're a Python coder and want to write a wrapper around it so that it can be inserted in the pipeline. If you are a Python coder, that's actually not a hard thing to do, but it will require some work. But typically, you would take the output from the texturing and then feed that into your into that program. Okay. So yeah, a lot of that went over your head, but do you understand where it would work and how?
Yep. Yep.
It just that there was a lot of talk about a square-shaped mesh versus a triangle-shaped mesh, and why one is better than the other. And
well, a lot of that depends on what you want to do with it. So the square-shaped mesh, from what I understand from reading the articles, was something that Blender uses a lot. I've not used Blender a lot myself, so it has not been of a concern to me. If you're doing 3D printing, that tends to use the triangles.
Right.
Yeah.
So the STLs are all triangle. So that, again, is less of a concern. But if you do have a large mesh, like you might get from a building or whatever, you can reduce it using that product as well. So that's a very single purpose product, I guess, for lack of a better description, but apparently does it very well. Okay, so let's see how our model is doing.
Just part of my pre-demonstration research that
yeah. And there's any number of tools like that out there. So one of the ones I'll show you a little bit later is Meshlab, and that's just to clean up this model. I don't use it to its full degree. I don't really understand all of the capabilities of it. I just know I can chop out some of the unwanted bits, and that's all I use it for at this point, because I've been concentrating a lot on the control software for this. I haven't really been getting into the practical artistic aspects of it, which is something I will need to get into as I get further in, but I just haven't got there yet. Will you go away?
It reminds me of GIMP as a program. I watched Darcy was doing some blog printing, and I laughed because he uses it exactly the way I do, which is to rescale an image and to crop, and that's it. Or change a format. It's got such a wonderful, rich, and it's got tons of other features, but yeah, it does the work. So yeah.
Well.
Yeah.
Okay, so now we have our mesh in here. So I'm going to double click on that. Okay, so that brought in the texturing. And there we go. Okay, so you can see that it didn't give us a complete scan of this one, but what it did give us was good. So with more images, we could actually get something decent out of the structure for motion. But again, that's where you would need a good set of reference points, because a lot of the magic that happened after, you can see how much the CUDA processing added to the overall mesh. So yeah, that's a pretty scary looking monkey head right now.
I actually am blown away. Like the parts that rendered are wonderfully detailed.
Yes. So you can see we actually have part of the mat. You
Yep.
can't see it so well on this one, but sometimes it's really freaky looking at the back side of things because it maps in reverse on the back.
Yep.
Because it's just literally a surface map. So
Yep.
yeah. So that's pretty cool. Okay, so let's look at some post-processing. Now, I've mentioned to you that a lot of this stuff goes into Meshroom cache. Let me see where I was. Okay, so let's go to Skull 3. Okay, so the output from the meshing. I don't know which one it was. Okay. I'm actually going to close Meshroom because MeshLab and Meshroom compete for the graphics card. Yeah, what are you doing? You're propping me for something. Close that too. And I'll bring up MeshLab. Okay, so this one actually does allow me to import into a project, but another way I can do it is just drag and drop. Okay. So this one has the similar user interface with the, the zoom in and zoom out and the 3D gizmo. But one of the things about just importing the mesh is you don't get all that texturing. So if you just want the object itself, you're not concerned with that texturing, this may be a good option for you. But the texturing can help you visualize what it is you're working with, because this is all a little bit indistinct where it's all the same color and so on. So I'm going to close that project. Create a new one. Okay, and go into the texturing. So with the textured mesh object, if I open that in the text editor, it comes up on the wrong screen because, of course, it has this mapping library, the textured mesh.mtl. And the textured mesh.mtl contains the mapping to the image files that are in that same directory. Okay, so if you are looking at transporting this mesh, you don't just need the OBJ file like you do for the mesh, you need the MTL and all the PNGs as well. Okay, but
those are the images that get wrapped?
Yeah.
Okay.
Open one of these. Okay, so yeah.
Wow.
This is just how all the stuff that is mapping onto the object itself, and it's just a PNG file. There's nothing too special about it. It does take a little longer to load, though.
It's an interesting way to unwrap an object, though.
I was thinking exactly that. I'm going
for a
wow.
painting or something. That's
Yeah, I know.
Well, basically, if you think about it, I mean, that mesh is just a series of triangles, right?
Mm-hmm.
So each of those triangles has an image.
Right. And then they've unfolded that.
Yeah.
And I assume if I painted or plotted that, I could roll it up into, I guess that's what that lady does, making those raccoons and things out of paper. Like they're low form poly, I think they call it, or Britta was doing that. Anyway, doesn't matter.
Right. I know what you're talking about. That yeah, you just need a flattening program.
Well, that's sort of what I mean. That image map.
Oh, this is different.
Yeah.
No, there is one. There is one.
Okay.
Okay, so now we have,
Oh, that's way easier to see.
it was,
Well,
I think I went too far. There we go.
there we go.
Stop. And like I said, you can see some of the crap that's in my shop. So obviously this is going to be a lot more than what it is you want to work with. So you want to clean some of this up. And this is actually what I use this particular program for. And I'm not seeing the tool that I need. Okay, so this is, so the selection tool is actually this one. So there are a couple of ways we can select. If we go in and edit select, you can select vertex clusters, vertexes on a plane, the vertexes, the faces in a rectangular region, the connected components, and so on. So typically what I do is just select a rectangular region. Okay, and then I can delete the current set of selected faces and vertexes, or vertices. Okay, so now that's all gone. And I can do that just by using smaller rectangles or so on, and I can obviously undo it. Or maybe I can't.
Does that also, when you do that, does that actually alter the texture PNG or whatever it was, or JPEG?
So at this point, no. It doesn't modify the external thing at all. So I can save this as a project, and when I'm done, I would
export it.
Export that mesh.
Ah, okay, thank you.
So it's definitely non-destructive. One of the things you do need to be aware of, so when I just deleted that one, I'm no longer in edit mode anymore. I'm back into a movement mode. So I have to select that mode every time. And another thing to be aware of, okay, if I select an image, it's not just, okay, I can hit escape here to go back to edit mode while keeping that there. That selection has infinite depth.
Oh, yes. So you just punched a hole clean through. Yeah.
Okay, now there are modifiers that you can use with that. Okay, hit escape again to go back to edit mode. So there's like Shift, Alt, Control, and so on. So you're going to want to play with those and just make sure that you're not destroying what it is you're trying to improve. So that's MeshLab.
Okay.
Obviously, this thing can do a lot more than that. You can do, alterations to the surface texture, to the lighting, and a whole bunch of other stuff. But there's any number of packages out there that can do that. I don't really want to dwell too much on this one, except to say that for cleanups like this is actually a very useful and simple tool.
Yeah.
Okay, and I think that's most of what I needed to cover. Here's my rerunning multiple pass. Oh, no, there's one other thing I want to cover. So I'm going to bring up Meshroom again. So calibration. Boom. So calibration, there is a separate node for it called camera calibration. And the input can be a few different things. It can be a folder of images. It can be a video, but not in a standard video format. There are some very specific formats for this. Again, that's in the documentation, but you probably don't want to do that anyway. So really what you're going to have is a series of images. And if I go to my software, I've actually gone about automating the calibration process a bit. So this is the sort of image you're looking at. What you have is you have a pattern of a known size. So these are 1-inch squares in a 6 by 9 grid, which may seem confusing because there's actually 10 by 7, except it's counting these as the start. And if you don't get that right, because it's not obvious, it can take you days to figure out until you go back and see that little note in the documentation. So there are a few patterns that are available for this. Chessboard circles, asymmetric circles, and asymmetric CC tag. And they are good for different purposes. The files for those are actually available from the Alice Vision website. You go into the photogrammetry, and I think it's in the localization. Yes, camera calibration. There is a link to camera calibration with OpenCV. And that actually describes a lot of what's going on here. So it does use the same method. And I believe if we go down to the bottom, that's where we find those files. Okay, so this is actually a pretty good video about how it all works. And there are a couple of patterns that you can use for doing this. So where are the files? Yeah, I can't remember where the files are. I thought I got them from here. So, yeah, I'd have to find where those are, but yeah. You can download the files. If you're looking for one, just send me a note and I'll send you the file if I haven't found it by then. But it is in the documentation somewhere to download those files. You don't have to create your own. And that's basically it. So a calibration file looks something like, actually, let's see what the inputs are. So it goes into the camera init, and it goes into the intrinsics. So you would add an element for each of the cameras you're using. And each of the intrinsics has an ID that it's going to use to match with the image. The image matching itself is done based on the serial number for the camera. So that way it matches to the camera. In the case of the Raspberry Pi, for example, that EXIF information wasn't in the standard camera capture software, so I actually had to add it myself. So for the serial number for the camera, it's actually the hardware ID for the Raspberry Pi board. But for things like an iPhone, it does include a serial number. Any of the Canon cameras or whatever will include that as well. The camera type. Okay. So generally radial 3 is what you're going to use, but yeah, you can use other ones as well. The resolution, the width, and the height. The serial number, this is what it's going to match from the EXIF data. The principal point is the center, and it's typically not width divided by 2. It's typically slightly off center, so it's like the visual center as opposed to the sensor center. And then you have some parameters for distortion. Okay, and I believe there's typically 3 elements in that one. Okay, so what I've done with mine, for example, is based on all these images, so I can just add an image by clicking add and then click on the camera as I'm going. Now, being web-based, I can do this from my cell phone. I don't have to be sitting at the computer to do this, but I do have to do this for each of the cameras in my scanning rig. And when you're doing this, you want to do it not always direct on, but slightly askew. You want to get it in each of the corners and things like that. And then when I'm done, I hit calculate. It creates a batch job, sends it off to my cluster for processing, and adds it to the database. So yeah, that's automated quite a bit. Yeah, so okay. Calibration. If you're using just one camera, the calibration isn't going to be overly critical unless you've got a lot of distortion in a lens or something like that. So it can certainly help with correction of that. But generally speaking, for a standard thing, like if you're using your iPhone or something like that, you're not going to have to worry about calibration.
Cool.
You mentioned stuff. I send it off to my cluster. Does the cluster require CUDA or is that CPU only?
My cluster is configured. Well, it's a single machine with CUDA. It's not a big cluster. So my pipeline, I could certainly, with what we've talked about here, I could certainly set it up to do processing that is non-CUDA. And I may actually do that as a rough approximation. But the goal for this, for me here, so I guess we can do some show and tell. So I have a session. So this would be like a session with a customer or whatever. When it was done, any tags, the artifacts, and so on. So as I create scans, they would be saved as an artifact and things like that. And then I would go in with the scanner. We get a preview. We can select which camera we're using for the preview. And I would enable my scanner, and then I can do a scan. Yep, and I have some ones in here previously. You can see me in my COVID business attire.
Yes.
Okay, so now with this particular scan highlighted, so this one, again, black is not a good color. I found that there was a big chunk missing from my side. Now I've also not, I don't have a complete camera array at this point, so I'm also, could benefit from a few more cameras. But that's basically it. And then to submit it to the system for processing.
This other
mesh. Okay, I'm having some issues there. I know I'm having some issues on this server, but see if I can. So I did get this one today. I put on a different shirt, so I'm not getting a black shirt issue. But let's see if I can. File not found.
No such file.
That's not good. Yeah, I've got some known issues with the server that I've been ignoring because it hasn't been in my priority. But basically, that's what I do to submit a job, and then I go to the jobs listing here, and it would show up.
When you talk to all those PyCams, are they? How do you talk to them? Like, is that
so
how are you aggregating data?
Code on there. They're each running a web service. If I go to my configuration.
Yep.
Okay. So one is designated a master, and it's got some software on there. And basically, I send it a signal saying, take an image. Okay. And then it sends a multicast signal to each of the slaves, which then takes an image, uploads it to a NFS share, which is sitting on my server.
Okay. And then you start processing.
Yeah. Oh. Now, I've got some other features in there, so I can monitor the temperature, for example. I can see what software version is running on there. I can do the previews and some things like that. But that's really some very basic Python code. But I'm certainly willing to share any of that.
It's neat.
So there were some gotchas because I'm using multicast and power over Ethernet. I've got a dedicated switch that does power over Ethernet for up to 24 devices. But I had to go in and enable multicast in there because routers by default don't have multicast enabled and things like that. So there was a bit of playing around to get it up and go on, but wasn't too bad.
Neat.
And they're all on a dedicated, so my server has dual Ethernet, so I just put them on one of the Ethernets and the other one is the rest of my network.
Yep.
Well, because this is going on the internet, maybe you should tell people what you're actually talking about, because we know because you've shown it to us before.
Where are we? Can you see it there?
Yeah.
I'll pick up my laptop. Okay, so this is my scanning rig. And I have a number of Raspberry Pi B, Pi 4s actually, with the power over Ethernet and the camera module. And I'm actually trying it with the Pi Zero with the wireless. it's certainly lower performance, and I am noticing that. But unfortunately, it doesn't have power over Ethernet, so I'm looking at some other both mounting options, obviously, because it's just masking tape right now, and power options. So I actually have a power supply that I want to feed into 6 or so of these. This is not the most stable platform, but it's certainly functional for testing.
So you'll be able to do an instant.
Yes.
Yes.
So because the goal here is to scan people move. So instead of, stay still for 3 minutes while we surround you with cameras, it's just going to take a single point in time image from multiple angles.
Okay, I think that'll help any future viewers.
Yeah,
valid point.
I think your first thing about taking pictures, make sure your model doesn't move.
Yes.
This solves that problem
Yes.
with humans.
And I actually thought of multiple ways of doing that, because obviously a large number of cameras can get expensive. So I thought about, just having one camera do, 3 images or something on a bit of a rail so it can move back and forth. But given the price of a Raspberry Pi with the camera module, especially if you're doing the wireless one, it's just more cost effective to have more cameras. And this also gives me the flexibility with the new camera modules available. I can upgrade to a better camera. Yeah, now I'm trying to cheat the system a bit where it says you want a 60% overlap. I'm trying to see how much I can squeeze out of that with less than 60% overlap. So I'm aiming at like maybe about 20% per side, which will give you a 40% with adjacent images. But yeah, that's significantly less than what they recommend, which ultimately may not work. So yeah, we'll see how that goes.
One sort of last. Go ahead.
How many cameras? I should say minimum, but I know it's all relative. But
yeah, so I mean, a lot of that is going to be subject to experimentation. Right now, counting the wireless one, I have 13. I'm looking at a minimum of 30, probably 60 is more practical.
Okay, so 30 times Raspberry Pi price. Okay, times plus camera.
Yeah, so I mean, it adds up, and that's one of the reasons why the cost per camera is important. You can't get commercial rigs out there that are, all Nikon SLRs.
But it's going to be the most awesome Beowulf cluster.
Yes. Yeah, again, it's memory limited, and we're running the high resolution camera that takes up a significant chunk of memory as well, dedicated to the video. So, especially on the Pi Zeros, you don't get a lot of processing power left. The Pi 4s are actually pretty good. I'm really quite impressed with those. Those are usable machines.
One other, just curious, I remember way back people were using those raster scan things that people played games with. I don't know what they were called. It was a bar that raster scanned infrared light on the players, and as they played a game.
Oh, right. That used to be available with Xbox or something like that.
Yeah, whatever that thing was. So interesting technology. Does raster scanning a bunch of dots help alleviate the requirement for more cameras, because you can sort of get
that's essentially what the cameras are doing.
Okay, I just wondered if the dots actually helped you coordinate how they fit together.
So, I mean, the short answer is yes, it does, because I mean, what it's doing is it's giving you reference points.
Yes.
But those reference points have to overlap in the images. So you will see in the motion suits that people do for motion capture and visual effects and things like that. I mean, that's fundamentally exactly what they're doing. So you have a reference point for exactly where that point in space and time is. So again, some things that help that: wearing a plaid shirt, having a background. So right now my background's pretty plain. I hung the picture up there today, but that hadn't been there in the past. So all of those things. Now again, this camera rig is eventually going to be a wraparound, so I can put some patterns on the rig itself, and even just having the cameras there, they act as reference points as well, because Mexican firing squad, you'll be able to see the camera. It all helps. It all helps. Everything you can have as a reference, it helps. Now, with that background referencing, though, that's where the cleanup for things like Mesh Lab become important, because you've got it is going to include that in your final textured image. So you need to be able to chop that out.
Okay.
And there are some ways you can do reduce that. It talks about that in the tutorial about altering the camera view angle so you can focus in on your central object, but there are some limits to that too. So as it stands right now with the techniques I'm using, there is going to be some post-processing cleanup.
Okay. Wow. My head's going to explode. That's a lot of information.
And yet it's just touching the surface.
No, I understand that, but that was great.
Yes, thank you.
Yes, I appreciate that. I'm going to go check out some of these sites, do a little bit more reading, and.
So in terms of links, I will send some out to the email list so that you can refer to them offline.
Yes, yeah, exactly.
Put them on the YouTube page, yeah, under the video, yeah.
Yeah. Perfect.
You manage that then, Darcy, the YouTube stuff?
Absolutely. You send me anything, I'll put it on there, yeah? Or I'll even give you the key to the YouTube channel if you want.
He'll give you the keys to the moon banana.
Maybe we should stop live streaming now?
Yeah.
Oh yeah, good idea. Then
You were quiet through this.
We can do our trash talking.
Were you actually listening in, or were you?
Oh yeah, I've been just here working as I was going,
Yeah.
and making some noise. But I'm trying to find the button now to stop the YouTube.
For left-hand
Stop
corner.
the share too, I guess.